Okay, we are going to continue our discussion on surfaces. So just a brief review. If trying to quantify and visualize surfaces, well, first thing, you should have a surface in you should be able to identify a surface in your image. And for that, you often need ample resolution. Otherwise, you can still try to identify surface, but you will likely have trouble. So most of these images at the first part basically don't have enough resolution until you get to pore scale images that have actual interfaces resolved. And some of these interfaces are better resolved than the others, such as the nature of resolving things in porous media. But here, for instance, if you see basically the surfaces between air in this image and everything else is a little better defined than any other. So basically, even this resolution would be likely a good choice. The moment you have three phases, finding thresholds between them is a little difficult. And here, you can find pretty good solution despite the noise, because resolution is pretty good, so we can likely process this to get quality surfaces. So all of the discussion that we had on quality of segmentation applies here, because essentially you will get the surface well if you can actually get individual phases well resolved in the image. Now, what is a surface? Surface is technically a lower resolution. So one thing that we commented on is that for porosity and saturation, something that is a volumetric average of volumes in the image, counting voxels is okay. And that feature, even if when your segmentation is not very good and has some sort of relatively random noise in there, you're going to actually do rather well by just counting voxels if you're just focused on finding what porosity is. Okay. However, if you actually want to get the objects and get the surfaces in between the objects, then that can be prone to noise, and the noise can be pretty problematic. So simple thresholding will actually often give you a relatively good numeric result. And you don't have to have a quality segmentation for that result to look okay or to match well with your lab data. However, noise specifically near and this is where you're likely to have more noise near the interface of two phases, and that's where your increased your resolution is typically not as good, and you will have much more noise near the interfaces than otherwise. Then getting a good surface really depends on also being able to segment the image as well. So not okay to count voxels, and we had that example where even when you do segmentation, basically based on the orientation of your surfaces, you might actually find quite some errors, because there's no way, you will always have these corners that you cannot avoid, and there's no way to approach. So I'm not gonna redo the lecture from last time. But our surface is essentially finding the surface. The basic algorithm, what it does is it finds neighborhoods. So these are what's shown here is the center of each voxel. So I don't see all of the sides that they share, because otherwise this would be really busy. But the basic idea is to walk through all of the clusters of 8 neighboring voxels in 3D and basically find triangulated surfaces, which can be actually tabulated. All of the possible cases can be tabulated. So find triangulated surfaces that divide one phase from the other. So let's pick a rather complex one this time that I didn't point next time. So basically, if I had something like this, okay, then basically these are my black voxels and these are my white voxels, Then to separate them, one thing that I know, so I basically walk the line in between two voxel centers, and if they're of differing phase, then I have to place a vertex in between. So if the simplest option is right in the middle, or I could scale it and slide it based on what is my threshold value versus what are the grayscale values if I'm working with the grayscale image here. If I'm working with the segmented image, then the only option is right in between. Okay? So essentially, I will place a vertex here, 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 and here, 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 and here. Okay? And then, so the only two sides that don't have a vertex is this one and this one, the only two lines. And then I just have to make sure to place surfaces such that they separate these black voxels from the white ones. And then the second choice I have to make is how I'm going to triangulate. So in this particular case, I could have a triangle this way or the other way, it doesn't matter. Okay? As long as you do the same rule and apply it consistently throughout. So I basically march through all of the cubes of 8 in my image and assemble these surfaces. Obviously, they can grow quite large. Okay. Now let's do an exercise in surface generation. So load that sphere data that we know, and let's just work with that. So we actually had this was 8-bit data. If you don't have a binarized image, then you typically, for these isosurfaces, should binarize it, or otherwise know a threshold value where you want to put your surface. So I'm going to put this on a side and open Fiji. And hopefully that will not close down any video recording I have. So for this you have to import data, import raw. So there is this raw data. If you actually go into this sphere, then you would load the TIFF images, and those you have to binarize. This one you don't have to binarize if you import raw. There we go. So there are two options. One plugin is 3D Viewer, and another one is BoneJ as a surface. I did not install BoneJ. Well, that's why I was contacting my office computer, which I won't do now, so I don't close down any. Oh, well, maybe I will not. Oh, it has an exception, but it's running. Okay. We'll see for how long. So, there are two options here. One is volume. You want surface. Volume will simply kind of take a voxel and shade it. It's going to look good, but it's not surface visualization in itself. Okay? So you can work fine for what you need, but I'm not going to do volume right now. I'm going to do surface. And I'm not going to resample. Resampling basically means lowering down your resolution. So if something is a very large image, you probably want to resample, or otherwise you won't be able to get the surface. This is quite an intense operation. Okay?
What's the threshold?
Threshold, so my data, so that depends on, so pick a color you'd like.
Okay,
depends on your data. This is segmented data in image J. Image J has segmented data 0 to 55. Okay? Otherwise, it depends on your data. Okay? So threshold has to be in between the phases that you want it to be. So I'm going to work with 127 because that's a midpoint in between the two values. Let's see if this actually now works. Okay. Okay. It works. And you can see a little bit of a staircase effect. Did you resample? That's what's making it smoother, not the bone J itself. So resampling will make it smoother. And they do a little bit of smoothing on this 2x2x2 or 3x3x3. I'm not sure when you put resampling 2 whether they use what kernel type do they use, but it's basically a neighborhood. Okay? And we know that digitization of neighborhoods is what the actual size of the neighborhood can be a little bit discussed. But the smoothing effect is basically there is a smoothing kernel operating on that nerve. That makes for better appearance. Okay. Now bone J, and you can also work with that analyze particles, which is placed in this. When you install bone J, this is where it's placed. So you can please do a couple of resamplings to see the differences. Let's try it once again, 3D viewer. Oh, there are Java exceptions big time on my computer now. So this analyze particle analyzers, which is something that is put on your computer using image J. So please do 3 different samples, so no resampling and then 3 different resamplings. And record the area. Okay. Look at what the resample, because if you want to measure, so for visual effects, you can do whatever you want for visual effects. And you want to make things look smoother for visual effects. This is not convincing as a sphere, is it? It's a little rough. Even though that's what the actual data underlying it is. And we understand that no matter what the resolution is, I'm going to have some of these effects, okay? That notwithstanding, do not present this as a sphere in your paper, okay? However, if you measure the area, you do want to go and seriously look into what do these resamplings and what do they do to the area. Some error will be there for sure. And whenever you live with some error, it's fine to live with the error. We have to do that. But you should also know how much error. So again, run the particle analyzer. And again, the way smoothing operation works is that if I move up and down these boundaries, they're going to look smoother. So if I look over a larger neighborhood, I can kind of do interpolation in that neighborhood. And then the boundary will not look as sharp like it does here. I think my image viewer is stuck now on this. If you want to do any serious computation, these things are a piece of. I'm not gonna name. I got it quickly to replace my old machine, and I'm still mourning my old machine, which was twice heavier but actually usable. I know, and I need to sit down with both of it, and I'm not sitting down. And I worked it out in my office for that reason, and then I realized that the recording of the video will not necessarily work if I'm doing remote desktop. So it seems that I cannot get to the... Granted, as long as you get to try, I think that's your memory will work well if you try. Whatever you watch me do is not necessarily helpful anyway.
Because when I do this, it'll let me get the surface area. If I click on this, I lose forward.
Okay, so this, when you redo it, it's going to always replace this number.
Yeah, but it won't let me change this one. It won't let me analyze this one. It'll only analyze this one because this is the only time when it.
Yes, so your plugin works on this image. This is just the visualization. Okay? So area is computed at the time this is produced, and it's always in this result. So you do have to possibly record the result because it's going to replace it by the next value. So that results then in image J is sort of like a default thing that everything goes to, so it can be overwritten. The level of resampling does impact area. Now it's also overwriting that result. So record it, and then you can also work with that, yes, so that will also give you the areas as well. You just have to do show areas. There's the area on the list. So there's multiple possible menus where you can get the areas. Show surfaces. Yes, surface area. As long as surface area is. So you actually have working on this. You know which class? Well, that's doing something for this class, okay? So 3. Oh, it's still working. So you can see, like when there's a log on one of these computers, there's a log isosurface contains however many triangles. So you can see that with higher resampling you get less triangles, right? Because you're resampling over larger. So it's basically just placing one interface in a larger neighborhood. So whatever algorithm I showed you, it works on a neighboring voxel, your original resolution. When you resample, you take a larger neighborhood and you still kind of like interpolate it in place. You still behave as it's only 8x8 voxel, even though it's a larger neighborhood. Okay? So that way you have less volume to work, then you're essentially reducing resolution. But what's done inside is interpolation, so it still looks in the right place, right? but smaller features will be lost necessarily. So instead of, let's do in two by two, right? Let's say that I have something like this. These are my voxel pixel centers. So if I was working with the original resolution, I would go 4 by 4, right? And place something from these neighborhoods of 4, right? With a larger one, let's say that I'm resampling and I'm doing this, okay? Then I'm going to interpolate this to just 4 values and place the interface somewhere in between. And I'm going to work only with this interpolated version. And that will basically reduce my resolution. Imagine that you resampled your entire, so this is now 4 by 4. You could have reduced that into 2 by 2 image, okay? And with each of these replaced by average or median. Yes? That could be one way to resample. I think what is done underneath is just interpolation of values on a different grid. So whatever grid I want to, I have original values, okay? Whatever it is that I want, however I want to resample, I put a new grid on top of this and interpolate on this new grid. I interpolate based on the existing data. Just linear interpolation. That's it. There's an algorithm for that. I could do bicubic, I could do bilinear, whatever. And that's often reused whenever you have missing data. Let's say that you are in petroleum engineering. You have well sites, right? And you have certain grid that you need to compute on. You're going to interpolate on the grid you need to compute on. You never have data on the grid you need to compute on. Okay? You use the data you have to constrain your interpolation. So basically create a new interpolated field. And that's what these things do as well. So there's a grid where you have the measurement, and then a grid where you want the measurements to be, right? And those two, in 99% of the cases, do not match. Okay? So you get the existing ones simply by fixing the values here, and then any other value, wherever it is that you need it, you find by interpolation. And that could be on some irregular or regular grid, doesn't matter. So interpolation is one of the key things to do whenever you have numerical methods in play, including visualization. Yes?
So like kind of like trying to vary the number of the surface.
Yes.
So kind of utilize some wrong.
Yeah, so why would they increase here? So I guess you introduce more and more error, and regardless, the sampling of 6 is essentially averaging more, but for some reason you get more surface area. It's actually bouncing back and forth.
Yeah, what I did is I used properly analyzed.
Yes.
Just
I will show the surfaces so you can see the type of surface that you need. So show surfaces in 3D so they can see the difference. Oh, so that's both. I don't know what that does. Right, it's just put them above each other. Go a little further. this could be a little bit of because as I'm smoothing down these effects, it should go down. And at some point, when okay.
So go down and then back up. Every time I get to 6,
I think at some point, basically, you just stop resampling those little hills. Normally, resampling kills small features that would typically reduce the area. What is happening when you start increasing? I'm quite not certain. Some of you will see that there's volume resampling and surface resampling. I don't know what does it do when you click both. That's great. That's a great question. I actually don't know. So that's something. Whatever it is, test it first. And this one, we know the diameters. So try to get from some of these diameters. Try to get what your volume should be. 4/3 times 5 times r cubed. Yes. So some of it is digitization effects as well.
Dr. B,
Yes.
how do we know the real radius of the figure? Is it a good approximation if we go